Everyone, welcome back to the shop. Today we're going to eliminate my most hated weld of all, the one that's inside of a piece of tube. So what I need is this small piece of tubing to slide over the top of this piece of 2-inch. Now what's stopping me from doing that is the stupid weld seam inside this tubing. And I hate that weld. It's my least favorite weld of all time. But if you need a telescoping fit, you can buy seamless tube to do this. You can get it in just about any size. You can get it in round, you can get it in rectangle, you can get it in square. And depending on where you live, it may not be readily available to you. It's also more expensive. So removing the seam out of a small section of tubing for a small project is actually a pretty good idea. I'm going to show you the 4 or 5 different methods that I've used over the years to get rid of the weld seam. From a short piece, then build a cheap tool for the long sections. You'd be surprised how easy it is just to peel that weld right out of there with just a simple chisel and a hammer. The one I'm using is a Proto. This is a 3/4 by 12 with a 7/8 cut on the tip. This is my go-to tool. I have to remove it out of a short section of tubing. Another tool I like to use is one of these finger sanders. It uses a 3/8 wide belt. The one I'm using here is a Chicago pneumatic. Turns at like 22,000 RPMs. Be sure to get lots of belts if you have one of these things because it likes to use them up pretty fast. And make sure you turn them in the right direction too, because if you don't, the belts like to break. The die grinder, which I call the devil's sliver maker. This thing's pretty effective at removing the weld, but you get all these little filings everywhere and they're just a pain in the to get rid of. You can get a whole bunch of different style burrs. They're kind of expensive to purchase, but once you got them, they last quite a while. If you have more time than patience, a file also works. This one's just a half-round bastard file, pretty coarse, and it probably takes about 2 to 3 minutes. You can rough out a weld pretty quickly if it's a small section of tubing, but it's simple and effective. Fire also can remove the weld seam out of there. If you're good with a torch, this is a great option. If you're not good with a torch, you'll probably destroy your tubing, but it is quick and it is effective, especially on larger tubing where that weld seam is pretty big. A scarfing tip works awesome to remove that weld. If you have some extra free time on your hands, go to the scrap bin, grab some of these small sections of tubing and bust out the torch and just practice trying to scarf that weld out of there. It really will help with your torch skills. And then when you do need to be able to remove that weld, man, you're ready to go. I'm not a real big fan of grinding a groove on the outside of this tube. I think it looks unprofessional, but if this is your only option, it does work. The chisel, the file, all those things work great on short sections, but what do we do on longer pieces? I want to show you the tool that I made to remove that pesky weld out of there. You need a piece of high-speed steel, a piece of all thread, a few nuts, an end cap, the actual slug material itself, and that's about it. Really pretty simple. We're going to drag this piece of high-speed steel through the inside diameter of this tubing, much like how a shaper works. If you're not familiar with a shaper, I have a video on that. It's pretty interesting to watch, so go check that out. But we need a way to hold this piece of high-speed steel. So I've cut 3 inches off the tube that I actually want to fit inside of this. Then measured where the weld seam is located and transferred that onto our little slug here. I've then scribed the width of the high-speed steel onto the surface of the tubing and came down about 1 inch or so. That way we got at least a good 1/2 of an inch inside of the tube to help it get started and drag straight. You can use a bandsaw or you can use a skinny wheel to make this little groove. After we got the groove in, I just stick it in the vise and I literally peen over the 2 little arms that are left. That way we've got a nice good little channel for this piece of high-speed steel to sit in. It doesn't have to be too precision. Now looking at the high-speed steel itself, it needs to measure the exact width of the male tube that's going inside of the female. When you do cut the high-speed steel to length, you can't take this to the bandsaw. You're gonna have to use a skinny wheel or some sort of abrasive cutoff to cut it. You don't need to make it oversized, just make it the exact length and you can grind that really close with either a belt grinder or a flat disc. I basically want the high-speed steel to have a square back end, which is going to ride against the inside wall opposite of the weld seam. The cutting edge could also be square or neutral. If you're not familiar with the way high-speed steel works, you don't have to worry about sharpening it. In order to drag the slug through the tubing, we need to use a piece of all thread. I like to use the biggest piece that I can and get as close to the cutting edge of that piece of high-speed steel. And we're gonna make basically a cap for the back. We're gonna drill a hole, weld a nut, and we're gonna get that hole as close to the cutting edge as possible. That's gonna prevent the slug binding as it walks its way through the inside of the tubing. Be careful not to over weld the nut because you'll distort it. Just some good tacks to keep it from twisting off. And the weld seam on these tubes are never the same, so you might end up over the years making a couple different ones where different weld seams are. I'm gonna cut the rod to length and then weld a nut on the end of it so I have a way to grip the all thread and twist it. To start the assembly, you just need a stop on the back just to cap it. Just something to block it because we're gonna be pulling on the edge of the tube. And I like to put a washer on the end because there's gonna be quite a bit of friction there. Give yourself a little bit of a starting point by chiseling out a good inch or so. If you squeeze too hard on the vise, you're gonna pinch the slug. And two, if you put a little bit of an angle, your chips will roll out so they get bound up. A little shot of lube. Okay, here we go. Switch to the back of the vise, probably squeezing on it. There we are. Let's see if we can kick it back. Okay, just clean up the ends a little bit. You could also make this to where you could just use your press and punch it through. That's pretty simple too. But I wanted to show you the all thread technique. So this is a pretty slick option if you only need one or two of these pieces and you don't have any seamless tubing available to you at the moment. Over the years I've collected a couple different sizes and I keep all the rods and I just have stuff them in a drawer in my toolbox. If you're looking for high-speed steel, you can find it on eBay or Amazon. This stuff is cheap and I suggest keeping some in your toolbox at all times. I know what you're all thinking. How do we remove the weld out of a piece of tubing or pipe? We're gonna have to implement something a little bit different. I think we can still pull a slug or some sort of cutting device through the center of the tubing, but that's gonna pose some problems. Because there's no reference surface, the cutting edge is probably gonna move around the tubing if we try to pull it through. So here's what I'd like to try. I'm gonna cut a section of this bar stock off and I wanna push it through the center of this tube. But this bar is way too soft to have any sort of cutting edge on it. So I want to actually weld a cutting edge on the outside circumference of this bar, and then we'll sharpen it on the grinder, and then we'll try to push it through. Here's the slug that I want to push through the pipe. I want to put a chamfer all the way around 360 degrees around this edge. I'm looking for maybe a bevel that looks something more in line with the body, something like that. That way we can fill it in with the metal and then come back and grind it or put it in the lathe and turn it back to diameter again. I'm going to be using this UTP 711B. This is a hard facing rod used in excavating equipment. I keep it listed around the shop for all sorts of good stuff. The UTP specs, I think it says it'll get to like 60 Rockwell, which is pretty hard. I don't want to arc weld this weld seam around the top. I actually want to use this as a TIG filler, so I'm going to knock all the flux off of it and then use the TIG to actually apply this filler metal. It's going to allow me to precision place the amount and the thickness of the weld bead. I want a lot of material around the edge because I'm going to grind it off, so I'm going to use the lay wire technique just to build up a big fatty weld on top of this edge. just because I'm curious, we're gonna hit this weld with the file, see how hard it is. It's not like super hard. You can tell this is just mild steel back here, you hear it? It's just soft, quiet. And here's the top. Has that distinct hard skating feel to it. So now what I want to do is I'm just going to grind the shoulder square. I want a square flat top cutting edge. That way when this thing decides if it wants to twist inside of that piece of pipe, that it will always have a continuous cutting edge to ride against. All right, there's the final slug, the cutting slug. I've only got about 10 minutes into this so far, and it feels pretty sharp to my finger. Hopefully it's strong enough to rip that weld out of the inside of the pipe. I don't know, is it gonna work? Is it not gonna work? We're gonna find out. Would you look at that? Ha ha ha! It's working, guys. Ow! Hey, pinch my finger. Yep, more chips. That worked actually really good. I can barely feel it with my fingertip. Works slick. Nice trick. That worked better than I expected. Here's the slug. There's a little bit of edge damage right there, but man, look at that. That's a 1/8 of an inch. Man, look how much more cutting edge I have. I could use this slug over and over and over again. Well guys, this actually worked really good, way better than I expected. This is one of the reasons why I really love metalworking. I had no idea this would actually work. It's fun to be able to experiment and try new things. Hopefully this might help you on a problem you might have on the future trying to remove a weld seam. I know I'm gonna probably use it again too. So I'm gonna stash this little slug in my toolbox for next time, and I'll catch you on the next one. How many times? I think I've said tubing at least 30 times in this video. Sheesh. Tube, tubing, tubing, tube, tubing, 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 and tube, tubing, tube, tubing, the tube, tube, tubing, tubing, tubes, tube, tubing, tubing, or tubing, tubing, tube.